And finally, a problem. Let's do the standard deal here. Here you are. And there's, you know, a siren or some sort of car with some sort of, I guess that's a car, with some sort of a little horn. We don't want to say a siren because if it's a siren, the frequency will be changing all the time. So let's imagine something with a constant. Let's imagine it's the mob, and there is a piccolo player, and they're making a sound, and as they approach you, 560 hertz, and then when they go by, it drops down to 480 hertz, which obviously, if they could hit that low of a note on a piccolo, would be impressive, but if anybody could do it, the mob could do it. Let's see, so here it's come back that way. And you got to remember in these problems, the source of the sound is really spherical waves. So I draw the wave going forward here, backwards here. That's really irrelevant. You assume it's a spherical wave just going in all directions. But the key is, when it was approaching, you heard a higher frequency. When it was receding, you heard a lower frequency. And the question is simply, how fast is it going? Is that enough information to figure out how fast it's going? So let's look. First, let's look when the source was moving. Oh, in all cases, the source is moving. In one case, it's approaching, and in one case, it's moving away. So when the source is moving toward us, we look at that one, and that was F plus equals 1 over 1 minus speed over speed of sound times F naught. So we say, okay, the F plus is the higher frequency, that's the 560. Okay. We don't know the frequency in the air. We're just talking about the frequency we hear, so the F plus. Also, F plus is not like a change in F, it is the actual new frequency that's heard. So 560 is the frequency that we're hearing. That's what goes for F plus, equals 1 over 1 minus the velocity of the source. That's what we were asked for, okay. V of the source over V, that's the speed of sound in air, and that is a constant, 343 meters per second. It's the standard value. Air is that fast. Times F naught, the actual frequency of the little vibrating column of air in the piccolo. What's a piccolo player called? Piccolist. Times, so we don't know what it is, F naught. So here we have one equation and two unknowns. That's unfortunate, but we also have more information here. When it moves away, we could say, use that equation, F minus equals 1 over 1 plus the thing we don't know, how fast it's moving away, right, over 343 times the same F naught that we don't know. Now we have a very fortunate situation known as two equations and two unknowns. So we just have to solve it, and the easy way is to drag these over here, and they're both equal to F naught, so just set them equal to each other. So I'm going to say 560 times this times 1 minus Vs over 343 equals F naught, but I can make this one equal to F naught. So equals 480 times 1 plus Vs over 343. Sorry, my V's are getting over. Avant-garde. There we go. And we just have to solve that. 560 minus 480 used to be 80. Okay, and then we're left with 480 times Vs over 343. Bring this one over, it's also positive. So negative 560 over 343 times Vs. So we get Vs is common to both of those, and we get this one came over 560 over 343 plus 480 over 343. And that's just a number. Okay? You could solve it and you get 80 equals Vs. It happens to be 3.02, 3.03. But you can see we're done now. Now we're down to numbers. And we get Vs equals 26.4 meters per second. Is that a reasonable physical speed for the mob? It is if they're in a car. I don't think they can run that fast. And that's not an insult. Fastest human in the world is like 10 meters per second. So the 26.4 meters per second, but it is a reasonable speed for an automobile, which is how we originally set up the problem. Good luck.